Hi, everyone. My name is David Robles, and I'm an electrical engineering student at the George Washington University. On behalf of Engineering Tomorrow, I'm delighted to welcome you to Inspire to Engineering video series. Engineering Tomorrow is a national nonprofit organization whose mission is to increase the number of high school students who enroll in college and pursue an engineering degree. In addition to offering field trips to our engineering labs and local construction sites in various cities, we also provide high school students with a virtual lab experience and virtual interviews with professional engineers from around the world who are leaders in their respective fields. These engineers share their career experiences and discuss unique engineering challenges they've solved and provide thoughtful insight and advice to inspiring engineers. Today, we're joined with an exceptional individual who studied his PhD in chemical engineering and has achieved decades of engineering experience from companies like GE to GIP. I'm pleased to introduce you to our guest, John Casey. Mr. Casey, thank you for joining us today.
You're most welcome, David.
Now, Mr. Casey, can you introduce yourself and tell us a bit about you and describe your path to becoming an engineer and what may have inspired you to pursue your profession?
Okay, thank you, David. I'll start at the very beginning and can explore the journey that I've been on for this past number of decades. My interest in engineering stems from a very, very young age. I was fortuitous to be a son of an engineer. My dad had a huge interest in all things mechanical, and I think that passed to me. And from a very young age, I was exposed to jigsaw puzzles, crystal radio sets, Lego, and indeed, given the fact that my intellect was triggered by these simple things, I ended up being quite destructive with toys, stripping them down, rebuilding them, or at least trying to rebuild them. And then as things evolved into earlier years, I ended up getting a real interest in cars. And my father used to do up cars for restoration himself. And it was just really sitting at the feet of a master, just looking and understanding how the mechanics of an engine are put together and how they're put back together again and make them all work. So there was always a passion and a hunger for understanding how things worked in the engineering field. And it was always, I suppose, uplifting to be in a position to see something that was a bag of bits and assemble it into something that was, frankly, a mechanical piece of art. At school, I excelled in, I suppose, the math and engineering side of things, chemistry, physics. Always loved the subjects insofar as learned something new, always triggered the intellect, and was always buoyed up by a passion to understand how things worked. And the whole idea of electrical engineering, chemical engineering came quite easily to me, and it drove a passion. So as I went through school, it was pretty much an incisive move for me to say I had to do an engineering or science type degree because that's where I saw the action. And from there, I did a PhD in chemical engineering, very exciting time in my life. I did a PhD in hydrogen oxygen fuel cells, which were really, really rewarding and interesting by way of being able to generate scientific papers. I think for my PhD, I generated something like 22 publications, which was awesome and really exciting, which then ultimately led me into an industry to say, I need something to really stretch me, really challenge me. And I think the choices were either go into industry or go into a research and development like role. And I think I struck the right balance. I was fortuitous enough to get a job with General Electric in the diamond division, that's industrial diamond synthesis, where we ended up converting graphite into industrial grade diamonds. From there, and I can explain this in more detail, I went into gem diamonds and then into a thing called waste or garbage, and I'll explain that later. And then recently with GIP, I've been working on aspects of the aviation industry associated with airports and the like. So it's a journey and a script I could have never written in terms of where I started off, but it's always been driven by a passion for understanding how things work, a passion for understanding how a technology can be applied, and then ultimately using that experience to build on further experience, which has kind of landed me in a role today that has a very, very far-reaching responsibility from finance to HR to engineering to operations to you name it. So I'm in a comfortable zone right now, I can tell you. So long may it continue.
That's fantastic. Thank you. And I heard you talk about a lot of your experience, and I just have to ask, what would you consider to be a career highlight, based on your experience in engineering?
You know, I always say there's a highlight, but then I always say there's always going to be something new tomorrow. And I've been so lucky that I've enjoyed that type of career cycle. When I was working in hydrogen oxygen fuel cells or working on catalyst systems that were unique and bespoke, and we ended up developing a recipe that was really effective in terms of electrical power generation. At that time, that was really important for me. My first scientific paper was really important for me. When I got my job with General Electric working on industrial diamonds, we developed several technology platforms where we improved our yields and reduced costs and improved the grade of diamond. And we didn't publish scientific papers because everything was a trade secret, but as a young engineer, that was really, really uplifting. And then when I went into a process where we applied high pressure, high temperature physics to gem diamonds, where we took brown, the color brown, naturally occurring gem diamonds, and we were able to convert them into colorless, yellow diamonds, pink diamonds, blue diamonds, black diamonds. For me, that was, and I suppose if it forced me to give a highlight, it has got to be that point in time. And this is the year of 1999, the year 2000. We had developed a technology that people had never seen or heard of or believed of. And we were, if we could have produced a whole forest of printed papers that would have been published in every journal known to man. But we elected to keep it a trade secret, which in hindsight was probably a bad idea. But it was the most rewarding and enriching time of my life to work on something that was a naturally occurring substance. And every day you saw something new, something different. And we learned and invented a whole new field of technology that, you know, some days I just came home smiling. Some days I went to work smiling, and during work I smiled. So I suppose I'm going to be selfish. I'm going to say, of all the things I've done, from a personal glory perspective, it has to be the gem diamond processing was the most enriching and most rewarding. In the latter part of my career, I suppose it's more about responsibility of general management and growing businesses and managing the P&L and making businesses more profitable and getting the buzz out of that. But from a personal level, as an engineer, I won't say it, but I will say it, as an anorak, I have to say it was the most personally rewarding time of my life.
That's amazing. Thank you so much for bringing us that insight. Now, John, I know we talked and you mentioned you believe there's no boundaries within engineering and the industry. Could you describe what you mean and how your own professional career has exemplified that?
Well, I suppose I stand back and I say, as a young kid, if I was to map the trajectory of my career from young engineering student to where I am today, if I plotted it out, I would say I would not be mentally stable or mentally right. You couldn't possibly navigate the journey I've been on. As I said, I started off working on hydrogen oxygen fuel cells. I then migrated into industrial diamonds, which is high pressure, high temperature physics, which felt like a natural progression, which involved a lot of process engineering, and it involved operations, and then it involved material science, and then it involved financial planning, and it involved a general management role as a senior engineering manager. So that gave me the first taste of very broad functional responsibilities that I sought to grow into in the fullness of time. Then I went into a startup business, which is the gem diamond business, which brought with it an opportunity for globalization, because we source our diamond in one part of the world, process them in another part of the world, and then sell them into another part of the world. So we got into the whole marketing aspect, we got into the whole sales and distribution, pricing, process control, and that was a business that grew from nothing, which was highly, highly, highly rewarding. And as an individual, to have that responsibility from the scientific development through to the technology development, through to the science, through to the profit and loss financial responsibility, it was a very, very serious, albeit small business, to learn and understand the tools of the trade. From there, as I said, I went into general management, where I ended up managing facilities with over 450 people employed across several different sites. And that has a different responsibility. It was technology for sure, but it was all about stability, about process, because we ran operations 24/7. It was making sure our people performed, we delivered on our numbers, and we always stayed ahead of the game by making sure that we had the best available science and technology to deliver the lowest cost. So that became a business for me. From there, I went into a waste management business, which was one of the first acquisitions of Global Infrastructure Partners. They bought a company called Biffa, which is a waste recycling business in the UK. And I went in there to apply technology to waste. Now, some may say that's not very exciting, especially when you come from a world of gem diamonds. But let me share with you, the technology in waste is very, very challenging, and it opens up a whole new world of understanding and indeed an ability to bring learnings from my last life and my experience in my previous roles to the world of waste. So in that role, in the first phase, we were focusing on, in essence, recycling paper, card, plastic, and just getting recycled value for that material. But you had to separate it out from general waste, which required a whole technology of sorting, shaping, and distribution of materials. We then worked on food waste, which is in essence the remnants of our dinner plates, or the remnants of a hotel waste, which very often is cross-contaminated with metals, glass, ceramics. And we ended up taking that material and converting it into electricity through a process of anaerobic digestion. And we built the biggest anaerobic digester in the world back in 2009, where we processed 150,000 tons of food waste a year, generating over 7 megawatts of electricity. So that was very rewarding, but very interesting technology. And, we ended up with developing a lot of trade secrets that remain in our gift today that we don't share, because it's quite challenging to process that amount of food waste in a biological metal tummy, which that's what it really is, and making sure you fulfill all the requirements of the biology so they generate all of the biomethane to generate the electricity we needed from that process. We also ran landfill gas systems. So historically, when waste or garbage has been thrown into landfill, if it's not correctly managed by way of capture of gas as an anaerobic generation of gas, you end up with leakage, which causes a lot of odor. But if you put in structured systems where you withdraw landfill gas, clean the gas, scrub the gas, dry the gas, and run it into a reciprocation engine, you can generate electricity. And I grew that business to a 200 megawatt business from landfill gas across 34 landfill sites. So again, something that you go from high pressure, high temperature physics into landfill gas to anaerobic digestion to plastic recycling. You say, wow, really? Are there any boundaries? Well, they're not. And then laterally in the last 18 months, I've been working with GIP on our airports, where we're working with security systems. So when members of the public seek to go through security, they have to get body scanned, which is making sure that they're not carrying any weapons. And we have to work with the best available technology, which is millimeter wave technology, to try and map out features of the human body and differentiate anything that might be concealed. And then laterally, we've been working on 3D X-ray imaging for making sure that we can map out what's in carry-on luggage into airport or into airplane fuselage. And then, of course, the most exciting one we've been working on is the utility of a runway. So in Gatwick, which is the single busiest runway in the world, we're trying to optimize the number of flights we can land and depart on the runway at any point in time. So we've been working on time-based separation of aircraft, looking at the tower radar separation of aircraft, and just optimizing how we stack the aircraft in the sky and bring them down just in time. So, I started off in this journey, started talking about industrial diamonds, and I've ended up talking about aircraft on a runway. As I said, I don't think you could draw a line through all of those moving parts and say there's symmetry in them, because I don't see it. But the important thing is, as you age and as you mature, you learn a whole lot, and we're always learning. And I think I've been so gifted to work with people that are sometimes more brighter than I am, but I suppose I've always gotten into intellectual curiosity to understand how things work, master that understanding, and then trying to deliver it against that. So that has always driven me. And again, so fortuitous just to be able to get to work every day with a new challenge and a new learning. It's boundaryless. I can't say anymore. It's just boundaryless.
No, you're absolutely right. I mean, starting from the gem industries to diamonds to waste industry, and even moving on to airlines, I mean, it truly is boundaryless. It's fascinating, and it's absolutely amazing. It's been a very, very enriching journey, and I hope it doesn't end here. The aviation industry is going through a very difficult time right now with COVID. But having said that, even the challenges of COVID, we're having to make sure we end up with cleansing systems that don't transmit COVID to, let's say, passenger security systems. So we're looking at the installation of UV lamps in our security tray systems to make sure that there's no transmission and no carryover of any virus or bacterial systems on security trays. So, my God, that's microbiology. That's UV radiation.
But as an engineer, you have to understand these things. And I suppose you always bring things down to the first principles of understanding how things work, how can you apply them, and how can you do it in a safe way, cost effectively, and in this instance, timely, so that people have confidence going to airports and making sure they don't have COVID transmission from a security trace surface. So every day, another challenge.
I believe it. So I have one more question for you. And a lot of the viewers here are thinking about college and maybe heading towards college and maybe considering a degree in engineering. Do you have any advice or guidance or anything that you can share within your own experience maybe can help them?
Well, I have to say, if you want to be an engineer, you should have a curiosity as to how things work. You should have a passion for understanding that you can bring change. And you must get fun out of that. I think if we drift and if we just kind of trot along and don't seem to get engaged in the workings and the inner workings of things, I think we're missing a trick. If you fulfill that objective to say, you know what, I like things mechanical, I like things electrical, I like things engineering, I think that's the first tick in the box. And if you have that passion, make sure you just develop that passion. Engineering is hard work. See, I'm only 25 years of age, but that's grey hair. So it does bring with it stresses and strains, but so long as the balance of upside is always better than downside, I think it's a wonderful profession and a wonderful career path. I would say that, look, in engineering, it's always important to have an inquisitive mind and always important to ask questions. If you don't understand, ask and ask again. And, you know, if you don't get to the bottom or if you don't get to understand it, I think it always manifests in a later point where, you know, you make a misunderstanding and misjudgment. It's not to say we don't make errors, but just have that passion to ask. And if you don't ask, don't be ashamed to go and ask again, because the fundamentals of everything is the building blocks and the structure of how they all come together. So making sure you have that passion and that real desire to understand things in their simplest building blocks, I think is really, really important. And then, of course, teamwork. I think in an environment where you work in engineering, it's very seldom I come across engineers that are unique individual contributors. They do exist. They're brilliant people more often than not. But for me, when I do hit problems, it's about being able to network with people, be able to engage with them, to, in essence, share the problem, and share the intellectual experiences we've all had. And I think that's something that being able to work with people and get on with people is really, really important. And, you know, I always say in engineering, a shared problem is a solved problem. And there'll always be someone that can answer questions for you. We're not all experts in every dimension of our field, but more importantly, so long as we have that humility to say, look, I don't understand, but I have the humility to go and ask someone that has that knowledge and ask it in a way that's just Joe Soap, Commoner Gardner, please can you help me here? I think most engineers would welcome that and welcome the ability to transfer that knowledge. So, you know, I start and as I finish and say, have the passion for wanting to learn, have the passion for wanting to deliver, have the passion to excel, want to be the best in class, want to be the person that splits the new atom. Have that energy, have that focus, and then get to the bottom of it. Don't leave things half-baked. Try and bring things to execution, bring it to closure. And just, I can't say anymore, have that passion fired all the time. If you deliver, people will recognize, and then career paths will evolve. You'd be so lucky to have a path that just is defined, but maybe I consider that boring. I would say maybe best to explore every opportunity using your power and your skill to network and engage and have no boundaries. It's very rewarding.
Thank you, John. Thank you for joining us, and thank you absolutely for your insight. I think it's amazing and fascinating. Thank you so much for joining us.
You're most welcome, David. It's been my pleasure.